All right, Unit 2, Lesson 2, Page 2, Skill 2. Use the product property of radicals to simplify their higher roots. All right, so basically we're doing what we did with the square roots, only we're laser focused on the index. That's different than a 2 now. So the product rule still applies. It says if the indexes are the same, you can multiply them together under the radical sign. So if you can multiply them together, you can pull them apart. Okay? So 54 is not a perfect cube. That's not on the list of perfect cubes. So look through your list for the perfect cube that is a factor, which is 27. 54 divided by a 27 is a 2. Okay, so 20 cubed root of 27 is 3. So your final answer, as far as simplified goes, is 3 cubed root of 2. I should really put that somewhere. But, okay. So here's another one, the fourth root of 48. The 48 itself is not a perfect fourth, but it has a factor that is. So the fourth root of 48, think of the list of fourths. 1, 16, 81. So I would try the 16. So fourth root of 16. 48 divided by 16 goes in whole, and it's 3. So fourth root of 16 is a 2, 4, 3. That's my final answer, is the simplified version of the fourth root of 48. Okay, so let's try some of these. We've got 24. There's not very many. Think about it. Let's again write them down over and over again until you know them. So cubed roots: 1, 8, 27, 64, 125. So the only thing you can try is an 8, right? So 28 into 24 is 3. Cubed root of 8 is 2. What? Sorry, 2. Cubed root of 3. Okay, 160. It's a cube, so it's even. I would try that 64. 64 doesn't work in my calculator. 16, that kind of looks like an 8. Let's try an 8. So if I take out an 8, what do I have left? I have a 20 left. That's a big number. Let's think about the 20. Well, we're still talking cubes, so if an 8 doesn't go in, then 20 is the lowest. Then 20 doesn't have a perfect cube as a factor. Think about it. There's 2 2s and a 5. There's no cubes left, so 8 is correct. So the cubed root of 8 is 2. That's the best you can do. Okay. Ooh, there is a whopper number. Cubes, no. Fourths now. Think about fourths. What are some fourths? 16, 81, 256, 625. This ends in a 0. I'd try the 625. 624th root of 625. What is 1250 divided by 625? That comes out to a 2. We're good. Okay, so this is the fourth root of what? It's the perfect root of 5, right? This is 2, 3, 4, 5. This is 2, 3, 4, 5, right? So this is a 5, fourth root of 2. Oh, don't forget that 5. So 25, fourth root of 2. Okay? And let's see, cube 128. 128 is not a perfect cube. I make sure I write the little indexes in here, because if I don't, I'm going to forget it in my final answer. And that's going to be a problem when I input my answer or write my answer on a test without the proper index in it. It is not a square root. Do not change it to a square root. You have to keep that 3 in there. Okay, so 128, let's see. Perfect cube, go back to my perfect cube list. 64 looks even, try a 64. 128 divided by 64 is 2. So 64 is the perfect cube of 4. There we go. And 64 and fifths. I didn't write down any of the fifths. The fifths, what do we have for the fifths? I have 32 and 243. That's all I have. So let's try a 32. So there's obviously more, right? This is 2, this is 3, there's 4, 5, and 6. They just don't come up that much, but you know how to find them. Fifth root, you just have to do the math for it. Fifth root of 32. 32 times 2 is 64. Fifth root of 32 is 2 times negative 1/6 is negative 12. Fifth root of 2. Done. Okay. And let's see, simplify variables. Okay, we got to use the variables now. Same principle applies that we did before. If you have the fifth root of x to the 15th, divide that 15 by the index, which is 5. That comes out to a whole number 3, so that translates into that as your final answer, because everything comes out. I didn't have any remainder. So divide everything out. All right, look at everything separately. So is 54 a perfect cube? It is not on the list. So 2 factors of 54. What's a factor pair of 54 that has a perfect cube in it? I always try the 27. 27 times 2 is 54. 27 is the perfect cube of 3. So just that is that part. Remember, we're dividing by 3, that's 1, so this comes out as just an A. Divide by 3, you get 2, so B comes out as a B squared. So my final answer is 3AB squared third. Oh, it's not right, 3 right there. Okay. Oh, wait. 2. Okay. Make sure you get all the little parts. All right, 725 doesn't sound like a perfect fifth. All I had was 32 and 243, so let's try the 243. 729 divided by 243 is 3. 243 is the perfect fifth of 3. Left, 5, 3. Okay, back here, x to the 10 divided by 5 is 2. So x squared comes out. Divided by 5 is 5. All right, so my final answer is 3x squared y 5. Fifth root of 3. Pay attention to all those little numbers and get them all in your answer, okay? Ninth root. Nobody talked about the ninth root of anything, but there's no numerical coefficient in there, so I'm not all that concerned. This is going to be to the ninth divided by 9 is 1, right? That's a 9, sorry. And 27 divided by 9, same principle applies. 27 divided by 9 is 3. So this is just x, y, 3. Okay. And one more skill here, and then we'll practice. So those are pretty much even x's. We have remainders now. So x to the 5th divided by 3 is 1 2/3. So my y divided by 6 is 2. Okay, so what came out? 1x came out, 2 y's came out, and there's leftover 2 x's. Don't forget to write the little 3 index back in there. Very important. Okay. A to the 4th divided by 4 is 1. That's just an A. B to the 7th divided by 4. 4, it only goes 1 with 3 left over. So that's B coming out. And then the 4th root of B to the 3rd. And then C just comes along. So my final answer is A, B, 4th root of B, 3, C. Okay. 625 is a perfect 4th for 5. 14 divided by 4. Put in your calculator, you get 3 and something, right? 3 times 4 is 12. So that means there's 2 remainders. However you want to write the remainders is up to you. But the important part is we're taking 3 p's out and we're leaving 2 in under the 4th root. So that is really my answer, 5p3. Be careful when you write them. Be very clear that your instructor can understand what's an exponent and what's an index. Nice and neatness is going to matter. You don't want to mistaking them for something else. So please be clear when you're writing. All right, 64 is not a perfect 5th. 32 is. 32 times 2. So 2, 5th root of 2, m to the 14th divided by 5, because that's the index, right? 5 goes in what? Twice to get a 10, with 4 remaining. So this is going to be m squared, 5th root of m4 in there. And then the p's all stay in there because there isn't a whole one there. All right, so my final answer is 2m squared, 5th root of 2, m4, p4. Okay? All right, then I'll do the practice in a minute.